with gravitational field. So gravitational field intensity we had seen. It's basically force per unit mass. So in the formula G mm by r square, 1 m gets cancelled. So I is equal to G m by r square. So this was one question, superposition principle. That means you have to add all of them vectorically. And if you're having a symmetrical system, you will take at the center it to be 0. Try with this question, 2 kg, 6 kg separated by 10 meters. You have to find out the point where gravitational field is 0. So from any of the masses, let me know. Now, whatever answer you will give your answer with respect to the mass. That 2 meters from 2 kg or 3 meters from 6 kg, like this. C class. Let me mark a point. Let's say this is x distance from 2 kg. So if total is 10 meters, this part is just x. So this becomes 10 minus x. Okay. Now at this point when we are calculating the gravitational field, the net gravitational field here, this will be 0. No, Abdullah. No, no. Check the calculations once again. Okay, yes, yes, please check Abdullah. So IA plus IB is 0. IA is basically equal to IB, then only they are able to cancel each other, and at this particular point you are getting gravitational field as 0. So what is IA? Means gravitational field at this point due to this 2 kg. So we had seen the general formula G m by R square. So this becomes G into mass is 2, R square, this is X square. Same when we're talking about here, this becomes G into 6 divided by 10 minus X whole square. G will be cancelled. 2 here we are left with 3. Right? Now see, or one thing let's do. Let's keep it like this only. Let's not even cancel this. Now see, when you are taking the roots, so this becomes root 2 by x equals to root 6 by 10 minus x. Cross multiply root 2. See, when you will cross multiply, this will become root 2 10 minus root 2 x is equal to root 2 6. Yes. So shift this on the other side. Root 2 10 will be equal to root 2 x plus root 2 6. Okay. Now see, from here, if you take x common, this is root 2 plus root 6 equal to 10 root 2. So x is equal to 10 root 2 divided by root 2 plus root 6. So this is from 2 meters. You can subtract this. This is x. So 10 minus x will be separation from 6 kg. Specific point is asked and you can calculate that. Note down this class. Then one more question we will see. Hey class, 4-point masses are placed at the vertices of a pentagon. So pentagon has how many sides?
5.
5, right? So pentagon has 5 sides, but the masses that are given, these are just 4 masses. So it's like pentagon is there, but every corner of the pentagon is not filled by a charge, right? 4-point masses are there. This is one, this is second, this is third, this is fourth. Now, because of these four, you have to tell the intensity at the center, right? Due to this, due to this, due to this, and due to this. All these are separated by the separation A. Now see, how will you solve this question? There's a very simple technique. In one line, you'll get the answer. Suppose, let us assume that there was one more charge. Let me name this as something. This is A, this is B, this is C, this is D, this is E. If there was one more charge over here, just assuming it hypothetically, what would have been the resultant at the center? Remember when we were just concluding the last class, I told you that for the symmetrical figures, the net electric field, net electric force, net gravitational field, net gravitational force, everything just becomes zero. Right? So gravitational field, I think we specifically talked about, and you people made the figures also. So this is also symmetrical figure. Pentagon, a regular pentagon is a symmetrical figure. So if the fifth charge is also present, then IB, IA plus IC plus ID plus IE, this will be 0. Yes. Now see, what is missing? Out of this, IE is not present. So what IE is equal to? IE is equal to IA plus IB plus IC plus ID negative. So what is the magnitude equal to? The magnitude is equal to gravitational field due to all the 4 ones. So that means gravitational field due to all the 4 ones. This you have to find out too. 4-point masses are present. You have to find out their field at the center. So the field due to all the, let me remove this minus sign, otherwise it will be confusing, because right now we are focusing on the magnitude. So because of all the 4, see, you can notice because of all the 4 charges, you are getting it equal to be, this to be equal to that of single charge. It means IE is what? IE is GM by A square, which is equal to the net gravitational field of all the 4 charges. So like this, you have to find this answer. Understood? See, you are assuming that if the fifth charge is there, it would be 0 because of symmetry. Now, this you have to find out, so which is equal to the magnitude of this. All right, note it down. Some more formulas I want you to write regarding hollow sphere and different conditions. First, note it down, then we'll see this. No, see, you will not add all the charges. We do not want the gravitational field due to this charge, right? If this was asked, then we would have added it. Since this sum is asked, this is equal to this, so we won't add it because the final answer is this only, gm by a square. Yes, Harsha. Final answer will be that of E only. Because the sum is ultimately coming to be equal of this, right? That's why. See, class, regarding spheres we didn't discuss. If you are having this hollow sphere means any type of particle, any type of charge is not coming within the sphere. All right. All the gravitational field, forces of attraction will be outside. Clear? Hollow sphere means something which is normal. Hollow sphere definition is same. Hollow sphere means which is empty from inside. That is fine. But one more thing that you have to remember, nothing goes inside it. As in, you won't be needing volume component. You won't be needing volume component in here. Now see, the formulas you have to remember, derivation you don't need to go through it, and this is also not very important from your class 11 perspective. Just have it in your mind, because just in case if a question comes, you should be able to handle the questions of sphere. Because spheres and point masses are analogous to each other. You can use spheres also, you can use point masses also. So that's why the formula of spheres are same. But because in spheres we have a point outside, we have a point on the surface, and we have a point inside. That's why variations occur. So that you have to keep in mind. Okay, class. So see, outside the formula is same. I is equal to gm by r square. But this r is no separation from the center. At the surface, what happens? This r becomes equal to the radius. So we'll be using capital R square over here. Don't use radius over here, and here you can use radius, and inside is 0 in any case, because I told you no force of attraction is there within inside it, so this is 0. Directly mark this as 0. Now how will you plot the graph? See, we have taken points from the center, surface. So r is equal to 0 at the center, that's small r, and r becomes equal to the surface, becomes equal to the radius at the surface. So any point in between these two becomes inside, and any point outside this radius becomes outside, any point greater than this. So small r is less than capital R inside, and outside means small r is greater. So see, it's 0 inside, 0 inside, that's why this is the graph. Then at the surface there is a value, and this is inversely proportional to the small r square outside. This is inversely proportional to small r square's value outside. See, this is I is inversely proportional to r square. That's why we are plotting the graph like this. Note down this, then solid sphere we'll see.
Can you go back up? Yeah, we can go back now.
See, for solid sphere, again you will have points outside, inside, and at the surface. So outside and surface are exactly the same. For inside, you will have G capital M into small r divided by r cube. This is the formula for inside. Alright, the solid sphere inside case is different, rest of the case is same. Note down this also, solid sphere. C class, the formula for axis of a ring. Circle, we know circle is this. So this is not, this is a sphere though. I'm talking about a ring. At the ring, this is the ring. This is the center of the ring. But if you view the ring from YZ axis, like this. See, if you view the ring from the YZ axis, then this axis which is coming, like this is this is in XY plane. If I shift it, this becomes in YZ plane. So this axis which is passing through it, at a particular point, at a certain separation from this axis, when we are finding out gravitational field, the formula is I is equal to G small m into R divided by R square plus small r square to the power 3/2. Now see, if you put the value of R as 0, means R at the center would be 0. See, this is the center. So R's value at the center would be 0, right? So field will also be 0. That's why for symmetrical figure, remember, I told you for circle, it will come out to be 0. And one more thing. See, gravitational field for a point mass. This is source mass, this is test mass, there's a separation R. Force is what? This comes separately. That's why I have also written it separately. Gmm by R square. So I is equal to Gmm by R square, force per unit mass, right? Because this is force per unit mass. So for a point mass also, same thing, Gm by R square. For point mass also, this is Gm by R square. And direction is towards the source mass. Source mass means which is producing the gravitational field. This is producing gravitational field. Also, this is static. This one is static mass. This is how you will identify this. Note it down. All right, class. So I'll not be able to take your class further. I'm not well today. On Thursday, we'll complete this lesson. A small portion is left, gravitational energy. This is over. We'll start with gravitational energy. All right, so this I'll now discuss in the next class itself because now I'll not